All right, sketching a derivative given a function's graph. The key here is to look for slopes of 0 on the original graph, because a slope of 0 on the original graph shows up as a y value of 0 on the derivative. So we have a slope of 0 here at this relative minimum, or maximum. We have a slope of 0 at this relative minimum, a slope of 0 here, and a slope of 0 here. As a result, I'm going to plot a y value of 0 at this x value. I'm going to plot a y value of 0 here for my derivative. I'm going to plot a y value of 0 here, and I'm going to plot a y value of 0 here. And now I'm going to erase all these extra markings, because it'll just get confusing if I don't. Now I'm going to look for other kind of easy to identify slopes on the red parent graph. Right about here, if you drew in a tangent line to the graph here, you'd have a slope of about 1, as you would here, as you would here. These are all like slopes of 1. So if the parent graph has a slope of 1, the derivative will have a y value of 1 at that same x value. So I'm going to plot a y value of 1 here, here, and here. And again, I'm going to erase my previous markings because it just gets too convoluted. Right about here I have a slope of -1. Right about here I have a slope of -1. So I'm going to plot y values of -1 here and here. And then erase the rest of my rough draft. And I've got enough points plotted now where I can kind of see what's happening. I've got another periodic kind of trig-looking curve that weaves its way through these points, and as a result I've shown the derivative graph.